Alright, here we go. Let's try and get this done quick. We're going to go through the three problems that people had an issue with. Do this really quick. Hopefully you can keep up. If not, stop the video, write some questions down, and we'll go from there. Let's start with question number one, talking about a marathon in ancient times, and they get you some funny answer, or some funny times, like 2.5 hours, and then like 38 minutes, and then they throw in a couple 27 seconds. Sure. The problem is everything is in different times, so you have to sit there and convert everything into seconds. Hopefully you understand. You can say 1 hour is 60 minutes, and then 1 minute is 60 seconds. Hopefully you do the math. 2.5 times 60 times 60 roughly comes out to 9,000 seconds. The same with minutes. You have 38 minutes times 1 minute gives you 60 seconds. 2,200 and no. 2,280, yes, right? No, I don't know. Hold on. Calculator should be 38 times 60. 2,280. Okay, cool. And then the 27 seconds adds in there. So 2,280 plus 27 plus 27 plus 9,000 gives you 11,307 seconds. Some of you actually on the test left it as that, which is a problem because that's in seconds. They also gave you another, they said the velocity was some crazy number like 5.28, 5.25 meters per second. Well, hopefully that's where you sat there and said, hey, that could be a problem because I don't know of another issue or velocity in seconds. I need distance. The only equation I have is velocity equals distance divided by delta t. I guess that's kind of convenient because I have delta t and I have velocity. So then you say 5.25 equals my distance. My time is 11,307. Multiply that by on both sides. So you cancel it on this side. And times 5.25 gives you a big number. 59361.75 equals your distance. Now a lot of you said, hey, I could leave it like that. But significant figures and significant digits say I can't. I've got 2 in the start of every one of those numbers. I've got 3 there. The least is 2. So I've got to take this down to 59,000 equals my distance. If I wanted to, I could say 5.9 kilometers equals my distance, and that's even better. But I think the question at hand actually told you to leave it in meters. So again, take a look at that one. It's kind of a way to go. So the second one we had a problem with was a bus speeding up, or I think it was a bus or a car or something like that. So it sat there and said, hey, the velocity of the car initially was like 120 kilometers per hour, and VF slows down to like 35 kilometers per hour in like a delta t of, I don't know, 38 seconds. Now a lot of you said, hey, I got this. Delta x equals 1/2 VF plus VI delta t. And you are partially correct. The problem is kilometers per hour to meters per second. 120 kilometers over 1 hour. 1 hour is equal to 3,600 seconds. And 1 kilometer is equal to 1,000 meters. Again, 120 times 1,000 divided by 3,600. Well, that's an easy number, 33.3, repeating. Same for the 35. 35 times 1,000 divided by 3,600. 9.72 repeating. Great numbers. So then I plug them in the equation. Delta x equals 1/2 VF 9.72 repeating plus 33.3 repeating times 38 seconds. Now if you have a handy dandy calculator, you can take those answers, plus, and scroll up, hit enter. So that middle part is 43 and that ugly number. Times 0.5 times 38 gives me a delta x of 818.0555 repeating. Now again, look at that, two significant digits, two significant digits, two significant digits. Delta x really should be 820 meters. Because it's 81, we round up, we have to put 820. The 0 is a placeholder. Two significant digits. Okay? So that's the second one everyone had a problem with. Now let's get to the third one. Third one is a little different because it has it speeding up and slowing down. So let's just do some simple numbers. Let's start with a VI. I think it started at rest. Let's go VF, we don't know. It gave you an acceleration, let's just say of 1.75 meters per second square. And a delta t of something crazy, let's see 16 seconds, I don't know. But that's not all it gave you. It also said, well, I'm going to hit the brakes. Well, I don't know what the velocity is at that point. I don't know what the final velocity becomes after I hit the brakes. But it gives me an acceleration, let's say negative 1.2 meters per second squared, and a delta t of 12 seconds, I don't know. Sure, let's just go with that. So good news is meters per second, and seconds, everything's happy and kind of fun. If you did the equations off page 58, you should have VF equals VI plus A delta t. Again, I'm going to use the VI in there because I just like to. You could pick the other equation. So it's 0 plus 1.75 times 16 equals my VF. So the VF on this first part, 1.75 times 16, should be 28, not 18. Well, that VF is now my VI at the beginning of the slowing down portion. The cool news is I have the one equation. It worked once, might as well use it again. VF equals 28 plus my acceleration, negative 1.2 times 12 seconds. So what is negative 1.2 times 12? Woo. Negative 14.4. Sorry, math wasn't working out for me. 28 plus a negative, you got that, VF. So my final velocity is 13.6 meters per second. Now, the problem is, again, significant digits, two decimal places. Looks like two decimal places everywhere. Really, it should be 14 meters per second. And again, I went through those kind of fast. Hopefully they make sense. Let me know what you think. We'll go through some more problems later, but this is for everyone that's getting a start.